Welcome back to Intro to Tech Skills, where we are well down the runway to getting started. In the previous session, we just learned about all the tools that developers would like to use while they're building and while they're creating. And now we're going to learn about one more tool in their toolbox, programming languages. I'm Jasmine Greenaway. I'm a cloud advocate at Microsoft, and we have a number of special guests who are experts in a variety of programming languages. Now, during this discussion, you might hear some terminology or verbiage that might be quite new to you, and that's okay because you can ask it in the chat. And in the chat, we have a variety of experts on a variety of technologies and programming languages that can answer that question for you. So don't be shy. And on that note, be sure to take notes, ask those questions, and get inspired. So without further ado, let's bring in our panelists. First, I'll ask them to introduce themselves by their name, what they do, what language they'll be covering, as well as the first project they built in any language. And we're going to go in alphabetical order, starting with Anders. Anders, take it away.
Thanks, Jasmine. Hi, I'm Anders Heilsberg. I'm a technical fellow in the developer division at Microsoft. I've been at Microsoft for 25 years and worked first as the language designer for C#, and now I'm working on the TypeScript open source project, and I'm covering TypeScript here today. The first commercial project I worked on goes back about 40 years. It was a predecessor of Turbo Pascal that was written in Z80 assembly code for an 8-bit microprocessor. So it's been a long time.
And my name is April Dunham. I'm a senior cloud advocate at Microsoft focused on the Power Platform. So I'm going to be covering the low-code, no-code space today. And my very first app that I built, non-production obviously, was a C# app for a game, like a Galaga type game. So I think a lot of us get started with game development in that. So that was my start.
Awesome. Hey, I'm David. I've been at Microsoft for 14 years. I'm an architect on the .NET team, and my first app that I've built in any language was a game in QBasic.
Great, thank you. Hi everyone, I'm Francesca. I'm a principal data scientist at Microsoft, and I've been in the field of data science, machine learning, and AI for all my career. Today I'm going to cover Python because I have to say most of the work that I do as a data scientist at Microsoft is done in Python. So I have been using a lot that programming language. I also wrote a book about machine learning for time series forecasting with Python. So Python is basically my best friend. And the first application I wrote in Python was many, many years ago. I'm not going to say how many years ago, but many, many years ago. And I was still a researcher, and I was working with many different data from patent, publication, social network data, and with Python I was able to build this application to investigate and measure the impact of external knowledge network on different innovation clusters. So I was extremely excited for that achievement, and thank you. Today I will share more about Python.
Amazing. Thank you all for sharing your first project. That's really inspiring, really awesome to hear. So let's talk about these languages that we're going to cover today. Now, briefly explain why someone would even want to get started with a language that you're representing today. And we'll go in the same order, starting with Anders.
Yeah, so why would you use TypeScript? Well, if you write code in JavaScript, which you probably do if you're doing any kind of front-end programming, then TypeScript can make you a lot more productive in a nutshell. JavaScript is a dynamic programming language that doesn't have a type system. And what TypeScript does is it adds a type system to JavaScript that exists only at development time. But because we have a type system, we can then provide excellent tooling that offers features such as statement completion and code refactoring and code navigation and so forth. For that reason, a lot of people today, more than 50% of professional JavaScript developers use TypeScript to write their JavaScript.
And from the low-code, no-code space, I think what makes it really unique is the fact that it really kind of expands many different tech areas. So you can kind of find something in it no matter what you want to focus on, whether it's website development, mobile app dev, workflow automation, AI. Low-code, no-code has functionality that can encompass all those different areas. And more importantly, the barrier to entry is pretty low compared to some other traditional languages as well. It's pretty easy to get started in the platform. So it's a really good technology and programming language, quote unquote, to get started with.
As for C Sharp has been around for about 20 years now. I think we had our 20th thing this year for .NET and C Sharp. And C Sharp is probably one of the only languages that supports the full spectrum of apps, from low-level systems applications to high-level mobile apps, client apps, web apps. So it kind of covers the full spectrum of application dev with C Sharp. Also, the tooling is incredible. I think one of the things .NET is known for and C Sharp is known for is great tooling. So the IntelliSense, all the features of VS to publish to Azure and to various places, that ecosystem is very strong, and it's what makes C Sharp, I think, a good place to start with.
Yes, and for Python, I think that it's two things. So the first one is the community that is very welcoming. And so if you are even a student or a professional that wants to get started with machine learning and data science, you find yourself really supported by this amazing community that build end-to-end applications, data science application in Python. So that I would say is the first aspect. The second aspect is, of course, the fact that Python offers this extensive library for data science and analytics. So there are many different Python libraries that contains functions, tools, methods to manage data and analyze also data so that you can build the real models. And the nice thing is that each of these libraries has a particular focus, with some library also managing image and text data, for example. Some other libraries are better for data mining, neural networks, data visualization. Just to give you a quick example, usually data scientists, they start with the pandas, which is great for, I would say, ingesting data and start just to get some first insights and statistics from your data set. Then there is NumPy, which is another great library for Python that is great for numerical computing. And then I want also to mention scikit-learn, which is another great library, especially if you're thinking about building a model in Python. And the last one that I want to mention, actually two that I want to mention that are more like the two libraries that I'm currently using for building end-to-end machine learning solutions are TensorFlow, which is great also in terms of support for deep learning, and PyTorch, which is another great library, especially if you want to work with image data, text data. So there are so many libraries that you can use. And the nice thing with Python is that as a data scientist, you don't really need to build the algorithm from scratch, but you have these machine learning frameworks that you can just leverage to get insights from your data. That is actually the most important part of our job as a data scientist.
Thank you all so much for sharing so many amazing things to learn and adopt and think about when you're thinking about a programming language. Have you out there in the audience ever tried any of these? What are your favorite things about them? Share them in the chat. We'd love to know. So let's move on to another question, because I heard something a little different from aside from the other language that we talked about today, specifically with you, April. So can you define to the audience what low code, no code means? And why can we consider it an option for building software?
Absolutely, great question. So low code, no code is really a bit different from, say, some of the other languages that we're covering today, in that you really primarily code through configuration in a graphical interface than, say, opening up Visual Studio Code and writing code. So it gives us, again, reduces the barrier to entry into actually developing applications and workflows and all of that. So it's a really good way to get started and gives us kind of a graphical interface where, say, if we have PowerPoint and maybe Excel skills, we can actually build applications with technology like the Power Power Platform, which is Microsoft's low-code, no-code suite of tools. And we have different ways to even get in the door. We have truly no-code ways of being able to drag controls on a screen and use like AI paired programming to be able to produce the formulas for you. And then there's a low-code aspect of knowing, say, a low-code formula language like PowerFX to add even more functionality into the applications that you built.
Amazing. Wow. We have just so many options to get started with building software and building software in general. Really mind-blowing. So let's talk about a different platform that we all might be slightly aware of because the majority of us use it throughout our day, throughout our lives, the web. And we're actually going to talk about two particular programming languages, C# and TypeScript. And we will call on Anders and David for this discussion. Because when you look at things like developer surveys, you notice that, at the top of the list, there's usually a lot of folks who are adopting some kind of web platform or web technology. So let's dive into this a little bit. So first, we're going to start with Anders. Now, when it comes to TypeScript and somebody searching TypeScript online, they may come across information on JavaScript as well. Can you tell us why that happens? Why does that happen?
Well, so TypeScript is a superset of JavaScript, which means that like anything that you can write in JavaScript, you can also write in TypeScript. But then on top of that, TypeScript adds the ability for you to write type annotations. And type annotations are basically a way for you as a programmer to indicate your intent when you're writing a program. For example, this parameter is going to be a number, and this property is a string, and so forth. And once you have these annotations and type declarations in your code, then we can check that you are actually programming according to your intentions. And we can point out to you places where you make mistakes, for example, where something could be null or undefined and you haven't actually made provisions for that. Also, when we have type annotations, we can build much better tooling. We can give you things like statement completion and code navigation, safe refactorings, and so forth. All of that is powered by the ability of the tool to understand the intent of your code, and that in turn you indicate by writing these type annotations. And then when you compile or transpile your TypeScript, then we remove all the type annotations. And so what the browser sees is just the JavaScript. So you basically start with JavaScript, we add more stuff for development time, and then it goes away again at runtime. And this has become a tremendously popular way to write medium to large JavaScript apps. And as I mentioned earlier, a huge portion of the world's JavaScript developers use TypeScript today to manage and write big apps.
Amazing. So it sounds like someone could try either or, either language. So, what considerations should somebody think about if they're trying to decide between TypeScript or JavaScript?
Well, first of all, in order to learn TypeScript, you have to learn JavaScript. So you can always start with JavaScript, but you will find as your JavaScript applications become bigger that you run across problems when you run the program because there are bugs that you had not foreseen. And it turns out that if you use a tool like TypeScript and you add type annotations, whatever, then we can do a lot more validation of your code before it runs. But it ultimately, TypeScript is JavaScript. It's sort of JavaScript with a type system on top.
Amazing. Thank you so much for sharing, Anders. So, David, we have some questions about C#. So as you mentioned before, C#, you can really find it anywhere in a lot of different applications. But I just want, like I said, the section we're talking about the web. But
Yep.
why is it so popular for the web? Why is it such a big deal in the web?
I think it's important to define the web as two different sections. There's front end development, there's back end development, and there's full stack. Typically, you'll see C# on the backend side of things. So you aren't running C# in the browser. You're running a front end in JavaScript. Could be React or Angular or any framework. And you're running a language on the back end. And C# is very popular on the back end as well for those things. So applications are typically comprised of the front end and the back end, and C# has a very popular framework for building applications on the back end. So typically, when you're building an application, you end up having you end up being split across different languages. But more recently, there was an advancement introduced called WebAssembly, which allows you to run other languages in the browser, right? So over the last, I want to say three years, we also could run C# not only on the back end, but on the front end. So you can build applications that span the full matrix of front end and back end, aka full stack, with C#, which is pretty cool.
Yeah, that's amazing. So just a follow-up question. It sounds like you could use something like TypeScript with C# together.
That's right. That's right. They pair pretty well together,
Definitely.
actually.
Yeah.
Amazing.
You definitely can. You can, of course, also use TypeScript on the back end with Node.js, or
Exactly.
you could use C# on, like David mentioned, on the front end. Although I would say the affinity is sort of that, JavaScript runs in the browser and C# runs on the back end. That's typically where you see these programming languages.
Yep.
Wow, amazing. That's really versatile. That's you can kind of mix and match and kind of decide on, where do you want your front end code to be and your back end code to be. Awesome. Great. So let's bring everybody in because I have a question for all of you for all of you. So, true or false? When you learn one language, it's easy to learn another. And let's go in that same order that we had, starting with Anders.
I would say that's true. First one is always the hardest one.
I gotta agree with Anders. It's definitely true.
I was gonna say yes, and I think it is mostly yes, but there is a thing where every different paradigm shift will introduce a new thing. So for example, in school, I remember I learned Prolog, and it looked like a language out of nowhere, right? So I think most languages follow kind of like the same paradigm, but then every now and then you meet like a functional language or a Prolog or something that's completely off the wall, but you have to rethink your life. So yes, for the most part.
I would say yes, that is true. It's also true that in data science, the most important aspect is really to get the answer to your questions through data. And so it doesn't really matter which type of language or tool or framework you want to use. I work with many data scientists who prefer, for example, to use R, which is an amazing language for data science. Most of the people right now in the industry, in the machine learning data science industry, they prefer to use Python. But I totally agree with the rest of this panel that once you learn a programming language, then you are ready to learn many others, depending on what you have to build and what type of answers you need to get from your data.
Amazing. That's so exciting for those of us listening in the chat. If you already know a programming language, let us know what you're trying to learn next. What are you attempting to learn next? We'd be excited to know. Thank you all for sharing that. I also agree that once you learn one, adopting another can be a little bit of a smoother sailing than the first time around. So, and I'm so glad that you brought up data, Francesca, because that's what we're going to transition into next. So let's bring up April and Francesca for this next discussion. Now, one really interesting fact about data is that if you were to compile all the data in the world, it's estimated to reach 175 zettabytes by 2025. And I believe it'll take I believe there's a fact that says it'll take a few million years to download on the world's fastest internet or something like that. Either way, that is a lot of data. So when we look at developer surveys, just going back to that point, we see that Python always seems to be at the top for things like machine learning, data science, artificial intelligence, and like just any kind of work with data in general. Francesca, why do you think that is?
This is a great question. Thank you, Jasmine, for asking this question. I really think that is due to again, the community. I really believe in the meaning and the sense of the community, and especially when it gets to data science. Data science is such a field that so broad and is attracting also people with a very diverse type of background, especially I'm referring in terms of education. I work with data scientists that have been studying psychology or physics or economics or data science and machine learning. And so the fact that we have this strong community that is not only building those frameworks that are key frameworks for developing your data science solution, but they are also helping you with learning the new concepts and also with debugging your own applications, I think is just amazing. And so this is for sure one, probably the biggest reason why. The other reason that I was probably mentioning also during the first part of this panel is the fact that Python is really the type of language that is supporting every single step of what I call the data science lifecycle. So usually when you are a data scientist, you immediately start looking at different data sources, and so you want to, of course, ingest those types of data sources, and then you want immediately to start playing with your data. And so we have so many libraries. I mentioned some of them earlier, like pandas, that really help with understanding the data and get a sense of what are the different variables that I can use to predict my target variable. The target variable usually is the variable that you want to predict, but also just in terms of data visualization, which is an excellent tool for data scientists, both at the beginning and at the end of the data science lifecycle, because you can use the data visualization to understand better your data, and you can use your data visualization also to show your results in front of any audience. And so just for data visualization, we have Matplotlib, which is great for any type of data visualization, Seaborn. Another one is ggplot. And so these just already give you an understanding of how much data visualization, that is again just one of the many steps during the data science lifecycle, has been supported by Python. And then once you get into more like the advanced steps, such as model building, training, and then also deployment, there are many other frameworks. I mentioned some of them. TensorFlow is an amazing community and really supports a lot, especially if you wanted to build more like deep learning solutions. But then we have PyTorch. Another great framework and library is Keras, that was really created and is actually right now it's very well integrated with other frameworks. So there is this sense of open source and support that the Python community has been giving to data scientists and machine learning engineers. That is really, in my opinion, the key why we hear now Python everywhere, every time that we think about data science and machine learning.
Wow. Yeah, it's so expansive. So you just, named, a bunch of just different libraries and tools that just make your experience in data science, artificial intelligence, machine learning richer and more productive. So could you give the aspiring machine learning scientist, data scientist, artificial intelligence engineer, if you could give them one piece of advice, what would you say? What advice would you give them in terms of being successful with Python in their space?
I would say really start with answering a specific question. Sometimes people and students, professionals also who want to move to a different career path, they think that really machine learning and data science is this complex architecture of algorithms, which is true, but those algorithms are there in order to answer a specific question. So I would say try as a sort of a side project or for your school project, try really to identify a specific question. Then the next step is to identify that type of data that can answer that question. And then start with a simple data exploration, like pandas. Again, it's a wonderful tool. I love pandas. That's why I mention it all the time. And also Matplotlib is another great library to use in combination with the pandas, and try to understand how this data set can help me answer that question. And then based on the different question and based on the different data that you have in front of you and the different also features, variables that you can leverage to answer that question, you're going to see that each question is going to give you like a better overview of what is the type of family, algorithm family that you can answer. It is a regression, it is a classification. It's more like a recommender system that you need in order to answer that question. And all these algorithms, they already have frameworks that are already built there for you. So again, it's not a matter of being expert of the specific algorithm, because you can leverage this framework in order to build your models. And then, of course, you're going to do a lot of additional things, such as finding the best set of parameters you will need to evaluate your model. But my suggestion, Jasmine, going back to your question, is really to start small, start with a question, start with a small data set, and try out these libraries, these Python libraries that can help you reach the answer to that question.
Amazing. Thank you, Francesca. That's great advice. So let's move on to data with low code, no code, and April. So what trends do you see, or what are developers doing with data in that space?
Well, a lot. I would say low code, no code is a great way to dip your toes in the data and artificial intelligence, machine learning kind of waters there. We can't talk data without talking about Power BI, which is Power Platform's low code, no code tool for data visualization and dashboard and reporting. So Francesca mentioned data visualization earlier. So tools like Power BI are kind of breaking down the silos to getting started with data analytics by giving us a way to drag and drop and easily build and get in data from different data sources and data warehouses and things like that, and create these interactive dashboards and actionable dashboards as well. So lots going on in that space, and I think millions and millions of people are using Power BI for that purpose. From an artificial intelligence standpoint as well, not only are low code, no code tools like the Power Platform using artificial intelligence to make the tools better, like through things like Power Apps Ideas, which actually lets you use natural language, and it's using AI behind the scenes to say, show me all items assigned to me, and it can actually produce the formula needed for that. But also things that were announced today at Builds, Power Apps Express Design is actually using Azure Cognitive Services object detection artificial intelligence model to be able to let you do things like sketch out an application you're building and the design of the app, or maybe use something like Figma to sketch out the design and recognize that object and turn it into a Power App with the Power Apps low code, no code app development tool for you, which is just mind blowing. But in addition to that, from an artificial intelligence standpoint, we can use that to build artificial intelligence capable applications through things like AI Builder, which gives us low code, no code, pre-built artificial intelligence models that we can plug and play in our apps, and even things like mixed reality with out of the box controls available in low code. So lots going on in that space. We're seeing huge advancements in adding these artificial intelligence, machine learning, and data capabilities into low code, no code technology.
Wow, that's really exciting to hear. So there's another question that I have for you in terms of low code, no code, because there's many developers who have been writing into like traditional programming languages as we know it are adopting these platforms. And in fact, there is a data source out there, or a source out there, that mentions that 70% of new applications developed by companies will use low code, which is a big deal. So, April, what considerations should someone take when deciding if they want to adopt a low code, no code platform, or write code as we traditionally know it?
Absolutely. Well, I would think the first thing I would take out of that is the or. I think it's not an or, it's an and. I think low code, no code technology is something that every person that wants to get into development should have in their tool belt. It's just another tool that we can use to help us increase our development velocity faster. So one of the statistics that I think they shared earlier, Bill, in one of the keynotes was 7.4 million developers are actually using low code, no code tools right now. So again, just something that we can add into our developer stack to help offload some of the work that we're doing as developers. And it's a great way, like I said, to dip your toes in the water if you don't want to commit to learning, C# or TypeScript or Python. You can get your foot in the door, and then they really augment each other well. There's this whole concept of something called fusion development, and it just means that you as a team are leveraging, say, traditional technologies, traditional programming languages, and low-code tools as well to build solutions. So again, it's back to not the and the or, it's using all of the tools available to you to be able to build business solutions. And it's going to be really important too as well, given the stat that you're sharing, that 70% of all enterprise app dev is going to be using low-code tools in some space. So I think like 9 in 10 developers say that knowing low code, no code has made them more marketable and has really helped their careers. So just something to add into your developer toolset.
Wow, that's super exciting. Thank you for sharing that. So one other thing I want to just mention about, these two kind of platforms we've been talking about with the data field as well and as web, all of these languages can work for either of those spaces. So don't feel that, just because I've been calling on specific people in this panel, it's not bound to those particular platforms or technologies. So I just want to call that out. So thank you all so much for sharing your expertise there. So we're going to bring everybody in for some final questions here before we wrap up. Okay, so are you all ready for this one? When was the last time you had to search online for how to do something in the language that you're representing today? And we'll go in alphabetical order, starting with Anders.
Yeah, I think that might have been the day before yesterday when I had to look up the exact semantics of the right-hand operand in JavaScript's for-in statement because we needed to change how the type checker checks it. So I'm looking up stuff all the time.
Same here. I'm constantly looking up stuff. It was probably just yesterday or the day before. I forgot how to write the expression inside a Power Automate or workflow tool in the Power Platform to format a date time. So date times are always the bane of my existence, and I'm constantly looking things up as well.
Funny, date time suck. So I think for me, C# added range and index syntax in C# 9, I think. And I couldn't recall the syntax to walk from the back of the array. I think it's caret. That's pretty fun. Yep.
And for me, it was actually last Friday. I was using automated machine learning on Azure machine learning to build a forecasting model. And I still remember that I didn't remember at the time how to set a few parameters for that AutoML library. That, by the way, is a Python-based library on Azure machine learning. And right now they do the support of classification, regression, forecasting, and image recognition. So it's a great Python library. And I didn't remember how to set a specific parameter. And so it was very nice for me because I just look for that type of information, and I found my answer on Docs, on the Microsoft Docs. And so I was very, very grateful to the product team that put that documentation together. But usually, honestly, between me and my team, we always look for things in Python because it's really impossible to remember everything about data science, machine learning, and the different Python libraries, the different parameters that you need to set. So looking for those type of information, and most importantly, looking for help from the community is really the key to grow and keep learning.
Amazing. Thank you all for sharing. So for those of you out there who have, those hundreds of tabs open, just know that you're not alone. No matter where you are in your journey, you will most likely need to refer to Docs. And also, big shout out to the folks who are focusing on Docs and making our development environment, our development productivity a lot more easier with clear and concise and helpful documentation. We appreciate you all out there. So a lot of us, a lot of folks who maybe adopt programming languages or who get into tech by way of programming are usually looking to take these skills to the job industry to be able to gain employment. So my question, and feel free anybody to answer this, is when should somebody feel confident about putting a language on their resume? Anybody, feel free to answer.
It's a hard one.
Yeah.
I remember in college, I had C++ on there, and I took it off immediately after my internship. So I would say maybe it comes with a level of like a number of years of proficiency and experience with language, using it kind of like day in, day out, over and over. So you kind of know the ins and outs, the general things, so that if someone were to interview you and ask you a question about the language, you could answer it confidently, right? It doesn't mean you have to know every small thing of the language, like every area, but I think you want to know the breadth of the language, and you want to have used it day in, day out, so that if a very obvious question came, how do you declare a variable in your language, like declare a function, like those things, etc. So I'd say a couple of years proficiency. 5, 3.
I agree. And also, I think with Python, if you had a couple of projects that you use with Python, I mean, you use Python actually to run those couple of projects, I would say put it on your resume. Always make sure that you specify the type of libraries you have used. If you use, like, for example, a specific data set, a public data set, of course, you can specify that, and try really to focus on what was the problem you were trying to answer, to solve. And I think, again, in the case of the data science and machine learning field, is not really about knowing everything about Python, but if you specify those couple of libraries that you are more familiar with, I'm sure that the interviewer is going to ask you more questions about those two libraries and is not going to ask you everything about Python. So I would say always be honest, and if you work on a couple of projects, let's try to focus on those real projects.
Amazing. Thank you all for sharing. Oh, Andres, I see you had more to add?
Well, I would perhaps add that it's sort of interesting in the time I've been in the industry. It used to be that the programming language was the hard part to learn. But today it's actually the frameworks and the libraries that make out the lion's share of your learning curve. And so I think it's important too, when you list on your resume, that you don't just list the languages but also the frameworks and tool sets that because they are very much the big part of the learning curve.
Yes, I 100% agree. Yeah, I have to say I learned that myself. Like my second or third career or job in my career, I was like, oh wait, it's not about what exactly but how do you can apply it to a particular problem. That's at least what I'm gathering from all of you that are sharing. Thank you so much for sharing your expertise. So take notes on that, folks. If you are really confident in the language, put it on your resume, and especially if you know how to solve problems with it. So on that note, we're going to ask you all one more question, and then we're going to turn it to the audience we have a very long list of questions, but we don't have much time. So we'll try to go through some really interesting ones here. But the final question that I have for you is, go back to a time when you were first using your language. And what would you tell yourself that you would like to share with all of us watching today? What would you tell yourself when you first wrote that first line or solved that first project? What would you like to tell yourself and share with the audience? And we'll go in alphabetical order.
You had to put me first, eh? It's tough because I mean I don't work I work on designing languages, and the thing you learn about designing languages is that you can add, but you can never take away. So as a language matures, you become painfully aware of the mistakes that you made early on, and you wish you could go fix them, but you can't, because then you break everybody's code. And there are, in every language I worked on, sadly, there are examples of those. I'm not gonna name them, but but that's sort of the name of the game, I would say.
Yeah, and I guess for me, it would just be probably just don't be too hard on yourself. You know, I mean, the earlier questions, like when do you put it on your resume? I think some people, if you're like me at all, tend to think that you really have to be an expert, you know, in something to even confidently list it, and what it takes 10,000 hours to really truly master anything, which is quite a while. So I would say don't be too hard on yourself, and don't be afraid to also reach out for help. And everyone has to research answers and remember how to do things every now and then. It's nothing to be ashamed of.
Interesting question. Thinking back, I mean, when I started coding, I don't think I knew how many hours I would spend at the screen staring at like text. I think that is a very that and the frustration when things don't work, and the joy when things do work. Like the highs and lows are in coding are kind of insane. I would say that that is super normal. So when you feel like you hit a wall and you're stuck, like that is part of coding. And the best developers have that same feeling of like I am super dumb, and then you solve it and you're like, I'm super smart. Like those highs and lows are very common. So when you hit those lows, don't feel as though like you're dumb or you're stuck. Like that happens to everyone.
Yeah, I think in my case, it was very hard. Again, I was still at school. I was not really working in the industry, but I was coding a lot, and I was working on a few research pipelines, and so it was very hard. But then I realized that it was the only thing for me, coding, that was kept me very awake at night. So usually when I have to read or I have to write, now it's more like writing emails. After a few minutes, I need to do fast because I want to finish. When I was starting coding, I could stay hours and hours coding. And that was hard because at the beginning, of course, I was failing a lot, but I could stay until 3 a.m., 4 a.m. coding. And so after a while, it became actually a very nice thing for me. And so probably what I would say to myself is just keep coding and enjoy it. Enjoy really the learning experience. Try to share also with others what you're trying to do, and don't be ashamed of the fact that at the beginning it's going to be extremely difficult. But it's good that I was enjoying it. So that's good. Thank you for asking this question, Justin.
Yeah, no problem. So we are almost at time. We have about a few minutes left. So this one is going to be a little bit shorter in terms of question before we wrap up. But how long did it take you to master your respective languages? We know that's a journey, but how long did you feel comfortable enough to say that you felt comfortable enough to put on your resume? And we'll go, feel free to either, we'll go in order again.
Well, I think April already mentioned the 10,000 hours, and honestly, when I look back at my beginning of my career and how long did it take for me to become really good at implementing compilers, it was probably about 10,000 hours. So I think it's important to have a passion. That really was what drove me through it. I didn't do it because I was getting paid for it, because I wasn't. I did it because it was my passion, and that's just such an important thing to have in the game.
Amazing. We'll have one more person answer, and then we will have to wrap up, unfortunately.
I agree, and this is exactly what I was trying to say before. That it's really about passion. I was not even counting hours and hours. If I have to give an exact number to that question, probably I would say if you have a few amounts of hours, a few hours during the day that you can spend on coding with Python, I would say anything between 6 to 12 months is a good way to feel like, okay, I now know very well how to master this specific library in Python. But again, that is very subjective. For me, again, it was just, I was driven by passion. Like I wasn't paid for what I was doing at that time. And if you can invest many, many hours during the day on coding, probably I would say something between 6-12 months is reasonable. Then you can feel confident enough to say, yes, I have been writing in this language.
Amazing. Thank you all so much for sharing your expertise. Anders, David, April, Francesca, thank you all so much. And if you out there in the audience would like to learn more about these languages, visit our repo, aka.ms, Intro to Tech Skills at Build. And stay tuned for our next session that puts these languages into practice, Hello World in 3 languages. We'll see you there and enjoy the rest of Build. See ya.